Hello, everyone. My name is Tuçe Erel. I'm very happy to welcome you back after our lunch break at Hackers, Makers, Thinkers Conference Day 1 at Design Transfer in person and also on live stream at our Artwork YouTube channel. And we are indeed very happy to be able to get together in the first day in this conference. And also let me thank again to our collaborators, Professor Dr. Michelle Christensen and Professor Dr. Florian Conradi, who are holding co-head positions at the research group Critical Maker Culture, Berlin University of Arts and Weizenbaum Institute, that they invited us to meet under this roof of design transfer and contributed to the program. Hackers, Makers, Thinkers, Collective Experiments in Social Fermenting is a series of events, workshops, performances, conference, and an exhibition. We kick off the program already in early May, and we open the doors of the exhibition on May 20th. Both at Art Laboratory Berlin and also our venue collaborator Okaka Ram 29. The exhibition will be available for a visit until the 10th of July, and more events and workshops will take place in the following weeks. In today's conference, we are excited to bring together artists and special guests around concepts like hacking, social fermentation, a term that used by the Rice Brewing Sisters Club, which you have already learned more in the previous panel, and maker culture. For our conceptualization, we use the term of hacking, as Mackenzie's work suggested. To hack is to differ. And I just realized that I'm still wearing my mask. Hello again. In this panel B, which is titled Symbiotic Elements, we will focus on the non-human hackers. We will welcome 4 speakers in the session, that 2 of them are artists of the exhibition, Cammack Lindsey and Irene Agrivina, as well as invited guests, Sénamé Koffi and Shujie. Our first speaker is in the session, is going to present online actually. Unfortunately, he's not available to attend this in-person meeting. That's why we're doing this wonderful hybrid program. And we're very happy to welcome Sénamé Koffi, who is an architect and anthropologist by training. He advocates a new vernacular concept that he concretely translates as an innovator, designer, and entrepreneur as a scale of product, building, and see. He is the founder of l'Africaine d'Architecture, excuse my French, which is not existing, a collaborative platform for research and experimentation on issues of African architecture and cities. He is also the founder of Relics, a network of Tongolese tech hubs that aim to make everyone equal in the face of the digital revolution. With his community, he contributes to prototyping a digital collectivism, which has made it possible to launch half a dozen startups in his work. He develops alternative visions on the issues of integrated architecture, primitive computationalities, technological democracy, and sustainable cities. His work has been acknowledged by, amongst other, by African Innovation Summit in 2014, the Global Fab Award in 2014, the Ashoka Foundation Fellow since 2017, and the African Leadership Award in 2018. In his virtual participation, he will present an ethics of entangled methods. The floor is yours.
Okay, thank you. So I didn't prepare anything special. I see it's most like a conversation. And I would like first to apologize in advance for my disastrous English. So I will just share some thoughts with you on these thematics. And as you know, all from a single neurosis center, an infection developed with such rapidity that very quickly there was not a corner of the planet that was not contaminated by it. I'm not talking about Corona, I'm talking about capitalism, of course, but we know that it is also in the bed of the violence made to the nature by liberal metropolization, and thanks to the leveling of communal system deemed unprofitable that viruses are formed and established and spread. So we have there two types of pandemics who share the same identity of method through the inconsistency they insinuate in the system of each. They disturb the traditional organic, social, and economical structure. But what I would like to share with you is this idea that it is not all with the virality. We have another type of viral, immersed, surreptitious colonist who propose himself more complex in the techno-industrial cyber system. So we have, on my point of view, a third manifestation of virality, and the last one recently endowed with technology, solutionism, and social acceptance in time of coronavirus. So those three levels of virus, the virus in biospherical structure, the virus in social structure, and the virus in technological structure, are surprisingly embedded. And just talk a little bit about the last one, the virality in as he used to manifest itself in the technology. The technology right now seems to be led by two claims. The first one is after trying for a long time to convince states to function like a company, the capitalism seems to have find it more feasible to transform company in states. So there is the first characteristic of the technological virality I'm talking about. The fact that business today want to be country and be ruled like country will be host in. The second manifestation is that, and for explain that, I would like to ask to the audience if you know what is the very first technology the humanity created.
Holes? The audience said that holes.
Holes, okay. Another one?
Anyone else? Language? Florian says language.
Okay. No, the very first technology the humanity created is the group, is the community. It is this idea to do things with others, because if you want to move a table, it is simple to do it with the help of someone instead of doing it yourself. Or if you want to remember everything I'm saying today, you will have a best result if you do it together than ask only one of you to do it. So the very first technology the humanity created was the social structure. And the second claim I'm talking about in the technology today who make it working like a virus is the fact that the technology for a long time was inspired by the social structure and was supposed to be at the service of the social structure. But with the digital revolution, we saw that technology don't want anymore to serve the social structure. Technology have this claim to become itself a social structure in which the humanity can be host, you know, so that we will visit technology as a new social structure. So this is the true claim of technology, who make it like a third level of abstraction. So the first level of abstraction is the fact that something tried to emancipate itself of the structure of the nature, which creates viruses, biological viruses. The second level of abstraction is these things we make with the economy by creating something who is supposed to be a tool, the economy, but who become a reality itself. So the economy was a tool who emancipated itself of the service of the structure. Now the economy have his own law. He take his opinion in itself, and he is not anymore managed in a sense by the social structure. And the last abstraction, or the last emancipation from the structure, is the one we are facing right now with the technological emancipation, who seems to be lead us to a sort of terminal imperialism, technological imperialism. So what I would just like to share with you, very simple, is if these three levels of abstraction in a sense coalesce or create an union of abstraction, we will have a sort of derealization. A new reality can emerge, which will not be a metaverse, but a reality very coherent, in this sense that it will be an alternative social, biological and technical coalition who can, in French we say subjuguer, who can make our natural reality not efficient anymore, and who can kill it. So what I want to express is this vision is a dystopia, of course, but is not a new thing. This dystopia, this three level of separation, who can create a different world, have his origin in the history, and specifically in the European history. All this begin with what we call in French les Lumières, with the 18th century, and with some thinker, some philosopher who are beginning to try to solve the problem of the hegemony of the church, and who create all these modern thoughts. And the modern thoughts was based on two separations. The first separation is what we call the naturalism. And it is this thought of Descartes that humanity are enslaved in the nature. And for the humans to be free, he needs to separate itself from the nature or dominate the nature. So it was the first separation, and it was a big moment in the history, maybe the biggest shift in our history, because before that, you don't have any civilization all over the world who consider that he can emancipate itself from the nature. And it is the European Center who invent this idea. And this idea was followed by a second separation. And this second separation is the separation between humans and humans. it was defined by this idea that after the separation with the nature, if you really want to be an emancipated human, you need to be separate from the group also for your tribal links from the family, in the sense that they don't help you to attain your full potential. So the Occidental philosophy or the European Center philosophy creates the individualism. And those two separations, individualism and naturalism, was the origin of this triple crisis. I try to sensibilize you to, which is this three level of emancipation from the structure or for the service of this, the structure. And the question today is to see how we can manage that, as we know that this global coup made by the West, who transformed his conviction in a software already now shared by all the humanity, didn't work because he created those separations who are the origin of a lot of problems we are facing right now. How can we change this reality, and how can we develop a new paradigm which is not a rationalist, naturalist and individualist paradigm, but which will be a paradigm of non-separation, a paradigm of entanglements. And just to give maybe one idea, I would like to propose to check in other geography what was the basis of their organic, non-separable idea philosophy. And this basis seems to be their cosmogony, because the cosmogony is something in traditional society who propose the social structure like something who is tightly entangled or net with the biospherical structure, because the cosmogony explains the totality by each one of his parts, and each part with the totality. So that leads by this concept, which is the cosmogony, people don't have this temptation, this ambition to create societies who make separation between humans and nature, and between humans and humans, and with what we are facing right now, between humans and his capacity, who are supposed to be manifest in technology or in tools. And just to illustrate that, I would like to share with you a cosmogony, but a cosmogony of Lele people. So Lele people are people you find in the middle of Africa. And in this society, you have a very interesting symbolical construction of non-separation or of tightly integration of everything based on pangolin. So I think most of you know this little animal. It is one of the animals who are facing his disparition right now, because he's a large hunt. He's one of the more beneficiaries business right now, more than the cocaine, etc. Pangolin traffic make a lot of money. So you have a lot of members of his species who are traded from Africa to China mainly. And pangolin, in fact, is a very inoffensive animal. It's a small, very small animal, but interesting for a lot of aspects. The first one is the fact that the pangolin, when you surprise him, he used to hide his head. So he didn't, I don't know how you say fuir. He didn't try to run away, but he hid his head. So Lele people say that pangolin is an animal who have conscience and who feel what in French we say la honte, you know. So they learn a lot of morality by observing pangolin. Pangolin is also an animal you can have in your house and trying to make it produce kids small pangolin. Pangolin lets itself die if he is in captivity. So Lele people say that it is an animal who teach the humanity the irreducibility to be not managed by this idea to make profits, but to live for this sort of radicality of existing, you know. As you know, pangolin is a border animal. He can live in water, he can climb to tree, he can stand like humans. So there is a very beautiful cosmogony in which the pangolin is the animal who brings the civilization to humans, and all the architecture of the Lele people and a lot of their social structure, their political structure are based in the observation of the pangolin. A lot of ritual also. By example, Lele people consider that the pangolin is a representation of the humans in the wild. And the wild itself have a representation between the human community, which is the chief, the king of Lele. So you have some ritual in which the king used to meet the pangolin to discuss the relation between human society and the wild society, and try to sign contracts, you know, so that this relation didn't create conflict. In fact, the pangolin cannot be hunted, and if it is, it's supposed to be regulated, but it is not the case anymore because those people lose more and more because of the urbanity, the remembrance of this very nice cosmogony who was for a long time a tool to make their societies embedded, very tightly integrated to the natural structure, the cosmical structure, etc., etc. So that this is the small story I would like to share with you. And by saying that, maybe we have a potential by exploring the conceptual paradigm people create, original one in Oda's geography, to try to find solution to the inefficacy or non-efficiency of the capitalist paradigm we have right now. Thank you.
Thank you, Sénamé. Thank you so much. Because Sénamé needs to attend to another event, so we will not be able to include him for our Q&A at the end. So if you have any immediate questions, we can ask one question to Sénamé before he leaves, in relation to the way that he's connecting with the technologies, how we are just socially the first technological invention, as you mentioned, as creating a community is the first technological invention that we had. Any comments or any questions to Sénamé before we move on? Because we will not be able to ask any questions in the Q&A. Florian.
Hi, Sénamé. Good to see you again. Yes, maybe just to elaborate on your suggestion, like how to, if we take your aspect of the pangolin, what would you suggest when we go back and look at those narratives and rituals? How do we entangle ourselves into the mess we have created?
Yes, I don't have a, a solution precisely, but I just saw that in very traditional societies, they have this organical way of seeing things who avoid the problem we have in our modern societies. And maybe we should build a new cosmogony, but a generally shared cosmogony today. And maybe it is the solution, but these cosmogony have these difficulties that the one we have to build should be shared by all the humanity. But the old cosmogony are embedded in very localized societies. So it is the challenge. And it is also a new cosmogony which, if you follow me very well, should have this power, not only to articulate the human structure ideally in the biospherical structure, but also to articulate the technological structure in the human structure without any point of disturbance.
Thank you so much for joining virtually to our conference, Hackers, Makers, Thinkers, Sénamé.
Thank you.
I would like to introduce our next speaker, Cammack Lindsey, whose work Holobion's Relics from the Revolution is on view at the Hackers, Makers, Thinkers collective experiments on social fermenting. Cammack Lindsey is an artist whose practice includes bioart, DIY techniques, and political music theater, expanding the space to redistribute stolen features through performances and installations. They work together with code, voice, sound, and materialization of magic, ghosts, and clouds. Based in Berlin, they produced their first 8-hour musical with M.I. Gliese. Is it correct? Ackerstadtpalast in May 2017, and in 2019 premiered their most recent musical composition, Visible Window, releasing the recording online with the label Quantum Natives. Their works have been presented in Berlin at Cave, State Studio, and How, and internationally at Café Otto, London, Ars Electronica, Linz, Rick's Open Fields, Riga, and Encuentro Tecnofeminista in Mexico City. Cammack Lindsey will talk about their science fiction, musical installation and performance, Holobiont Relics and the Revolution on the 7th of July, excerpts of compositions from Cyanotoxic Romance with Cammack Lindsey as a factory worker and featuring Hanika Fiosmand as artist-in-law. This will take place in PA 58 on July 7th. That we will announce it soon again.
Hello, everybody. How exciting. It's been 2 years of online happenings. So this is nice to be physically with people. Yes, and to see your eyes. It's very nice. Oh, no problem. I will begin and say, hold your applause for the end, in case you have a feeling you might want to applause in the middle. It's okay? When did a song become more than heartfelt? When did a song stop making our hearts melt? I've heard the song for so long, they've hushed out, and there's no way that they're stopping us now. When did a song become something to sell? When the words we forgot to our song somehow Now in my heart, I know our song, and I'll always remember and with you sing along. Never forget the songs of our past, the songs we sing together to forge a brighter path. Cyanobacteria evolved roughly 2.5 billion years ago, introducing for the first time oxygen and photosynthesis into our atmosphere, and encouraging and initiating the growth of life into what we know today, including mammals such as ourselves, and the evolution of all organisms. They are the largest and the most important group of bacteria on Earth. The habitats of cyanobacteria are limnic bodies of water, such as lakes and ponds and marine environments. They flourish in water that is salty, brackish, or fresh, in cold and hot springs, and environments where no other life, microalgae, can exist. Cyanobacteria have the impressive ability to colonize infertile substrates such as volcanic ash, desert sand, and rocks. They burrow hollows into limestone, sandstone, and they can withstand and survive in both extremely high and low temperatures. Cyanobacteria is often referred to as blue-green algae, but this is perhaps not true, as they are no algae at all, but a bacteria. But then what is the difference between algae and cyanobacteria? And I will explain to you with my beautiful drawing I did on the computer. So I will actually, what I'm referring to is green algae, so not a macro algae that you would think of as seaweed, but it's a small, like cyanobacteria, they're small microscopic microalgae or phytoplankton. And both can go through photosynthesis, trapping the light energy with the chlorophyll pigments that they can use to synthesize oxygen. I went too fast. So one of the main differences is that cyanobacteria is a prokaryotic organism and it lacks a nucleus and a mitochondria. And this is often referred to as something that is more primitive and basic compared to the green algae that has a nucleus and is so therefore eukaryotic. So within this definition and this separation of the both, you have also this something that I would say is not correct, is that we view something as more primitive because it's something more less evolved and doesn't have a center point of intelligence such as nucleus. And if you look in the green algae, they have something known as a chloroplast that the cyanobacteria does not have. Oh, I have to speak slow. And something they all have in common is that cyanobacteria, green algae, along with diatoms and dinoflagellates, which also have some sort of nucleus, are all within the group of microalgae or phytoplankton. So then what is a chloroplast that this green algae has, and as well the diatoms and the dinoflagellates, as well many other things on this earth, but I will stick today to phytoplankton and one group of organisms. So they all have a chloroplast. What is a chloroplast? A chloroplast actually is a cyanobacteria that lives inside plant cells, in which this is how they synthesize food for themselves. Billions and billions of years ago, cyanobacteria began to take up residency within certain, what we refer to as eukaryotic cells. As the good house guests they were, they would make food for their host. And the ancestors of these algae and their plants today, in return, have this chloroplast, which is actually the ancestral descendants of a cyanobacteria. So In other words, within this organelle chloroplast, there is a tiny cyanobacteria inside. Not exactly, but I like to think of it this way. An endosymbiosis, which I briefly touched on, is a symbiosis in which one of the symbiotic organisms lives inside the other. So in this case, you had the cyanobacteria that was living within the tiny cells. And then at some point, it didn't escape this host and it became a part of the host itself. Examples of this are the leaf slug, which is awfully cute, or the leaf, no, this is the leaf sheep or the leaf slug, but they're both the same, just different views of it. Yeah, and they have the algae chloroplasts within its own cells, and this is how it produces energy from itself by taking energy from the sun. Another example is the spotted salamander, which is partaking in endosymbiosis with the green algae. Then you have lichen, which are also an example of symbiosis with usually cyanobacteria, green algae. And then that gets us to humans. But if you look at humans, we all have within ourselves a mitochondria, which is as well an organelle that has a striking resemblance to that of the chloroplasts on the other side. And what scientists believe, because they look so similar, is that perhaps these organelles that we have in our cells that called the mitochondria are also descendants of the cyanobacteria that had undergone endosymbiosis and are still a part of us as a relic of the ancestral symbiosis within all humans and all life that has a mitochondria, such as the sea slug, leaf slug, the spotted salamander, the lichen, insects, cows, animals, plants. They all can be connected to the root of life through cyanobacteria. And we've all undergone this symbiosis with cyanobacteria within our history of existence. And through our language that is enforced through Disney or media, we have somehow separated this historical symbiosis, as instead of viewing nature or the cyanobacteria as something that is a part of us and irreplaceably a part of our history, we have made it this evil, not demonic, sorry, evil character who steals our humanity, such as in the Ariel movie, no, The Little Mermaid. The evil character steals the voice of Ariel while the prince is her future and her sustainability. But symbiosis shows us that trees of life often grow in on itself, and that species come together, fuse, and make new beings who start again. The coming together of branches, one can hear the fusing. The tree of life is a twisted, tangled, pulsing entity with roots, branches meeting underground and in midair to form new fruits and hybrids. In the 16th century, a pre-industrial society that would eventually blossom into what we know today as capitalism struggled with, at the time, popular beliefs of mysticism and magic. And they took rebellious bodies and they separated them and dissected them and publicly in anatomical theaters, as this was the beginning of how we would view the human body as something functional and mechanical, so that we could modify it and separate it from its mysticism that was popular at the time. And we could then control the human body to mechanicalize it for profit, for a rising bourgeoisie class within a capitalist system. So then by doing this, we took nature and man and we wielded it to the needs and the concepts of progress within the patriarchal structure of family and state. And yeah. So with all I've spoken about, how can we use this to forge new ideas and speculate using stories and songs, as often historically songs have proven as ways of storytelling and things passing through to each other, important instructions or history that we want to pass on to each other. And through this project Holobiont, I started to speculate, how can I combine a story that is including all rebellious bodies, such as cyanobacteria and the working class together. So this also becomes even more important today, as you see, since the 1970s, as a relic of climate change, you have cyanobacteria and algae have been starting to occur as toxic blooms and all over the world, due often to rising surface temperatures and over nutrients in the water due to like fertilizers. And you see this increase as well following the ending of the industrial revolution in the global north. So what is bad about these toxic blooms is that often they cut off the oxygen in the water which is quite bad for all the marine organisms living in the water, as they tend to die, as they also need oxygen as well. It is toxic to humans, can get into the water supply, and can cause severe liver damage. It depends on the type of toxin that is found within these blooms, and there's a very different kind, but they're quite bad. Here is one example in the Gulf of Mexico, at the Gulf of the Mississippi River, that is due often to the agricultural fertilizers, that because of overproduction of plants or of crops, it then over-fertilizes and goes into the river, and this occurs every time in the summer. No matter how they try to clean it up, it always returns. This past year, you had in Marmara Sea in Turkey, a sea snot or mucilage of different phytoplanktons as well. And you have still in the Mediterranean Sea, Ostreopsis, which is a dinoflagellate, and is also due to increasing seawater temperatures, and is as well, a lot of these algae were not natural to these environments and were often brought there through colonialism and imperialism. For example, the Ostreopsis only has existed or has found to be existing in the Mediterranean Sea after the opening of the Suez Canal. So then we spend a lot of money to try to get rid of these toxic blooms, but the idea is that we don't actually fix the root of the problem, because you can try to ease these conditions that lead to them, but then the root of the problem is the overproduction, for example, or so we have more occurrences of these toxic algae and cyanobacteria. So we think, how can we make them useful within our system? So we separate them from their toxins, and we consider how we can transform them into products such as biofuels and pharmaceuticals. And this is an example of a bioalgae farm. And we make them into little shampoos and spirulina powder that is very healthy and nutritious for you. And at the same time, we have a struggling working class that, as climate change persists and increases and affects their environment, our anger grows along with their toxins. So I wanted to create a story that brings together the toxins of the cyanobacteria with the anger of the working class. And that is how the installation came together. In the installation as well, I constructed and wrote a short story and sang an old song from Bertolt Brecht in the narrative, which is actually written from the perspective of a horse, which I switched to this installation to be the perspective of the cyanobacteria. And you have the sound within the space that is generated from the temperature and the pH of the cyanobacteria, as well from the temperature of the surrounding air and the installation that then intertwines itself all together to have a story with this perspective of this fictionalized worker in a factory with that of the stories of the cyanobacteria, which is interesting because temperature and pH within the cyanobacteria reactor that you see here, and that I have a cyanococcus, I can't say it so well, a cyanobacteria growing. At this point, after many years, it as well has a brown algae as well inside. But the pH and temperature creates quite a homeostasis within the installation, so kind of have this womb-like feeling that we are symbiotically undergoing this transformation together to bring our stories together. And I collected their data. Here's some of their data from 2020. And I as well analyzed it in neural networks to look at the patterns that are changing in the data temperatures, but not changing so much. But it's a still ongoing process for me because I really would like the sound of their growth, but I think at the moment I'm looking into spectrometry in order to analyze the cell growth of the cyanobacteria rather than the pH and temperature, because you can't get so much action, though that's also beautiful in a way. So then the reactor is as well, the light is being reflected from the reactor throughout the space that subjugates the space. So the idea is to feel the presence of the cyanobacteria around you, because often these blooms of toxic algae are growing in spaces that we are not seeing every day, as such as an ocean or lake, when a lot of us live in quite large cities and buildings and don't see so much nature. As well, I have created a fixated microscope. So instead of inspecting a microscope down, the microscope image of the cyanobacteria is projected around in the space. I may be going crazy with my hands. Yeah. And then the idea was to do a performance with them. Yes, there we go. More images. I think I'm coming to an end. Do I still have time? No. Oh, am I? Oh, you should tell me to stop. Oh. Oh, good. Okay. Well, thank you very much. And I hope it made sense to you.
Thank you so much for your presentation, Cammack. So as you heard at the very beginning, Cammack is going to perform more of that the July 7th. And then I would like to quickly introduce my next speaker, Irene, or Ira. Ira Agrivina. Was born and raised in Java, Indonesia, where the practice of science, myth, and tradition sometimes mixed into one. Irene is a founding member of the famous HONF Collective, as well as XX Lab, awarded the Next Idea Art and Technology Grant at Ars Electronica in 2015. As an artist, technologist, and educator, she works at the intersection between art, science, and technology, and is engaged in collaborative, cross-disciplinary, and multimedia actions responding to social, cultural, and environmental changes. Her projects have been presented internationally in IFVA, New Media Art Festival, Hong Kong in 2017, Fifth Anyang Public Arts Project in South Korea in 2016, Ars Electronica Festival, Linz, Austria in 2015, and Pixeleka Festival, Helsinki, Finland in 2013. So the floor is yours. I will just quickly open up your presentation.
Hello, I'm so happy to be here. And because now we can travel and gather again, for me it's kind of like a dream. After isolated for almost 2.5 years. And then yeah, so thank you also for the team of at Laboratory Berlin, Tuçe and Regina and Chris, so I can be here. And so I think I will present, I think, more ideas, because I think Cammack and after this Shujie will explain more about the Cyanobacteria. So my presentation is, I think, is more about the prototype and ideas of the use of this symbiosis of water fern and Cyanobacteria called Anabaena. This water fern is called Azolla. So the Azolla and Anabaena symbiosis has been called a superorganism that combines the individual talents of these two different organisms. And for me, it's very romantic because they kind of like married. And then this is kind of like perfect marriage because there is no divorce for them. If they divorce, so one of them will die. So the Cyanobacterium and Anabaena evolved during the early history of the Earth, like Cammack said before, and then this and 3 billion years ago, when the planet atmosphere was devoid of oxygen, and the other organism is, like I said before, is the fern Azolla. And because this unique symbiosis in which these two parts have successfully evolved into a system that makes important contribution to the ecology, fertilization, and biotechnology. And like I say, it's perfect marriage. It's kind of like Adam and Eve for me. And then we will see later the presentation of them as, and the symbiosis between Azolla with the Cyanobacterium Anabaena. In this perfect marriage, leaf vacuoles provide an ideal home for Anabaena, which draws down atmospheric nitrogens, and this fertilizes Azolla, making it one of the fastest growing plants on the planet, doubling its biomass every 2 to 3 days. Even so, its only requirements are air, light, and fresh water, and small quantities of nutrients. Azolla and Anabaena is the only known symbiosis in which this cyanobacterial partner is maintained throughout the plant's reproductive cycle, resulting in their co-evolution and the extreme efficiency of the Azolla Anabaena superorganism. This amazing symbiosis of these two creatures could bring great effects on CO2 and reduce climate change. And this is actually like the diagram of the use that can be used of this symbiosis. I cannot really see it, but I hope you can read it. And the project started when me and my collective Kolhon at 2013 is working with some farmers around around Java. And then it's continue when they ask, then they have some replacement of the chemical fertilizer. And then it turns out that Azolla Anabaena was used among the the farmers among Southeast Asia that as a biofertilizer centuries ago. But then there is also another use that I propose to the farmers, but then working with the local farmers in Java is not so easy because there are so many rituals, so many offering ceremony, blah, blah, blah. And then I have to use an anthropological anthropological way and background to introduce this Azolla and Anabaena for future smart farming. And there is this famous living goddess, not living is actually a myth, but then she's very well known, the rice goddess among Southeast Asia is called Dewi Sri in Southeast, in Java, Bali, and some other islands in Indonesia is called another name. And like we can see, is Mang Kwan Kau or Posop in Thailand, Nang Kosop in Laos, Ponagar in Vietnam and Cambodia. Maybe in Korea, they also have this famous rice goddess as the symbol of love and fertility. That's so called Dewi Sri in Java. And this is, so Dewi Sri is, the story is actually almost the same with the Asola and Anabena. So it's creatures fall down from the sky, and then it got married with a human. So it's like another symbiosis also of another creatures, and then her body and then become a rice, and then it's become a fertilizer for the rice field. And this is in Thailand. And this is another story, but still a bit similar in Myanmar and Laos. And this is in Cambodia, it's called Onagar. A bit different because this is a mother of thousands sons, and then it's become a country, Cambodia. One country in between Cambodia and Vietnam. And then there are so many mantras in Indonesia and praise according to this goddess. And when we started to plant or harvest, so we have to say this mantra, or when there is like storm like before, and then we say this mantra, and then disappears. We hope actually. Yes, I just collected the. Yeah, so the project is actually try to find the connection of these two different particles, and then at the same time is how actually it can be applied among the farmers in Southeast Asia. And so I come with the prototype first time when I did the residency at IVF Hong Kong, and then I continued at the NTU-CCA. So how to connect actually between this, what can I say? Sorry, I lost my English is broken apart. How to connect actually from this biotechnology with the prototype of a design actually that can be received easily with the farmers, because they live with their knowledge about the scientific is not the same from the scientific but from the scientific part, but how to use this protocol in the same way, and it can be very it can be accepted, and then it can be applied in the farm. So despite the technical engineering research and anthropological research about the connection between human culture and their environment was done, the myth about the goddess of fertility known as Dewi Sri and Kwangpo and Posop and Nangkosop and Ponagar in Cambodia, the beautiful goddess that fall down from the sky, and then Cammack actually this prototype, the first prototype. So this project trying to seek the relation between the earth and outer space, and using the photosynthesis and process of Asola and Anabena. And the other hand is trying to bring the goddess of rice alive by representing her as a physical representation of us as an Asola plant. So this Asola and Anabena known as the pioneer plants and microorganisms of the earth, while the goddess of fertility known as the one who brought the plants and living environment on earth. The connection between earth and sky, myth and rituals, linga and yoni, art and science will be made by representing the goddess of the source of life and the source food and of energy and sustainable prototype of a worship shrine. So this is actually a work that presented at the Art Laboratory Berlin. So this is the design of which the people in Java actually have this shrine. The farmers in Java usually have these shrines at their home. And this is shrine when they do the offering to this goddess. And then so the idea is to make this rain as the sustainable source of power and energy, and at the same time, it's actually make the goddess alive. So this prototype is I made the microbial fuel cell from the symbiosis of Azolla and Anabaena and turn it into sustainable power. And then at the same time, it can be used as biofertilizer, live food stock, and many other things. So thank you. And please see the exhibition at the laboratory.
Okay, so actually we started to have this like a connection between the capital system, how the technology is invented and what kind of technologies that we have been exploring. And then we just explore cyanobacteria as the first hacker on Earth. And so we started to have this like a kind of an artistic intervention, and we're closing the session with a scientific explanation of cyanobacteria. So I'm very happy to welcome Shujie Wu. She's a PhD candidate at biology at the Free University Berlin. She obtained her master's degree in science at the Department of Plant and Environmental Sciences, the University of Copenhagen in Agronomy, specializing in plant science. Wu also had a year of working experience of microalgae mediated biocontrol and biofertilizer, as well as strong background in plant pathology. Additionally, she has a keen interest in image analysis to explore biological research. Shujie Wu is currently conducting diversity of far-red cyanobacteria in extreme environments, supervised by Dr. Nunbeck. Wu investigates the microbial communities of West Sahara and Salt Lake that can support far-red light photosynthesis. Welcome, and the floor is yours, and I will quickly open your presentation.
Hello, everybody. My name is Shujie Wu from Institute of Biophysics, Free University of Berlin. Thank you so much to meet you here. And also thanks for Art Laboratory Berlin to give me this chance to sharing the story of the cyanobacteria and also my research. And if you have any question during my presentation, you can interrupt me and ask me the question. Thank you. So here I'm going to talk about my research about diversity of far-right cyanobacteria in extreme environment. So thanks for previous presentation already talk about some cyanobacteria, but I'm going to still talk about a little bit further of the cyanobacteria. What are they? They are a large and diverse group of photosynthetic prokaryote, and they are also the only photosynthetic bacteria that can produce oxygen. That means it has a huge contribution to the Earth, and we can see some detailed data which shown here. The marine bacteria produce more than 25% of the night primary productivities in the ocean, and also terrestrial and bacteria also contribute a lot to the global photosynthetic. And also this organism is very tough and a resilient organism. That means it can live almost in everywhere of the world, ranging from the fresh water and the seawater and underneath of the stone, sandy, or even inside of the plants. So maybe you will ask me, why do we study this topic? There's two main reasons. The first, of course, the cyanobacteria is very important. It's the first primary producer that can use live-derived photosynthesis to produce organism compounds and oxygen. And another, we are very interested in this, how this organism adapt to this extreme environment, especially in shaded environments like the desert and the salt lake. So now I have to give you one question. Can photosynthesis occur in dark condition? I hope all of you can answer this question after my presentation. So let's talk about more about the shaded environment. So what's happened on this environment? It's actually a far right light enriched in habitats. You can imagine when you you can imagine like when you see a leaf, why it's green? Have you considering about it? That because the leaves can absorb most of the blue and red light, which you can see this spectroscopy here, and they reflect the green light. So this is why you see the leaves and they are with the green color. But under this situation, how cyanobacteria can live inside or under this environment? They have few strategy. First, they develop a new symbiotic relationship with some plants like Azolla, which talked before, and this picture showing the symbiotic relationship with Balazol and cyanobacteria. But my research topic is more focused on how to use this far right light, which is invisible light in the environment. You can see some cyanobacteria still live underneath of the rock or this sandy stone, which find it in this Antarctic area. So how they use this far right light for the photosynthesis? Here is the answer, and there has a process called far right light photoactivation. During this process, that means it can grow under the far right light, and it can use this special light for their oxygenic photosynthesis. And for this, they create some new pigments which called chlorophyll D and chlorophyll F. And these are the new pigments chemical structure here. And not only they have these new pigments, they also have a new mechanic of the photosynthetic system inside. And with the cooperation of the PS2, they also have a very special antenna system. It's called phycobilism, which help the cyanobacteria harvest more widely light. And after this protein absorb the different light, they can pass through to the PS2, which they can use for further photosynthesis. So back to my topic, there's two major objectives for my research. First is isolate, identify, and study the diverse cyanobacteria which can supporting far right photosynthesis in extreme environment. And the second, we will further understand how this shaded habitat impact this far right cyanobacteria adaptation. And our hypothesis is far right cyanobacteria have advantage of being adapted to this extreme environment. And here is my method from my experiment. So first step, of course, we are going to collect those samples from natural, and the picture showing you the two extreme environment. One is West Sahara Desert, and another is Clifton, Australia, Salt Lake. And later, when bring back to the lab, I will isolate them and incubate them under white light and far right light. And further, I will do some morphological and spectroscopy analysis on them. And the second approach, I will extract their DNA and sequencing them and get some bioinformatics information to analyze their diversity. So to help you more easier understand what I'm doing on in the lab, there are some pictures from my experiment. So the first picture showing here is some sandy sample which collect from the underneath of the sand. You can see there's still some green stuff on the or inside of stone. Those are the cyanobacteria. And after that, I will take them to the small pieces and inoculate them into a liquid culture. And also, I will try to inoculate them solid culture to purify them. And the picture below are some microscopic picture from cyanobacteria. And the first one is from the normal light microscopic picture, which maybe you're not easy to see. They're actually the big one is the algae, and the cyanobacteria are those very small, tiny pieces which live together with the algae. This is what happened in most cases in natural environment. And also the picture, and based on their fluorescence properties, we can use confocal microscope to see them more clearly and beautifully under confocal microscopy, which are the picture from here. But because of the project, maybe you cannot see it very clearly, but it indicates different shape of the cyanobacteria under this environment. And don't forget, this organism is very small, and the bar here is around 30 nanometer. That means it's even hard to see them clearly under a normal microscopy. Yeah, and here's come to my results. So I, based on the confocal microscopic picture, I can clearly see their pigments located, and the magenta pigments show me the chlorophyll A and the phycobilly zones location, and the yellow channel shows the chlorophyll D and F, which you can compare the white light string and far right light string. There's only chlorophyll D and F appears in the far right light string, which indicate these new pigments help them adopt this special environment. And this is very beautiful pattern. We call it zebra pattern, like combined with the different pigments. And this is the base. And also you can see the difference between the white line and far right light string. The far right light string has the right shift of the fluorescence intensity compared to the white line. And later, when I collect their DNA and sequencing, I built a phylogenetic tree to analyze their diversity. And the streams which marked with this red bar indicate those streams have the far right light photosynthetic ability. And you can see that it's very diverse distributed in the whole cyanobacteria group. And also this green streams, it's the one I isolate from my study. So the summary of my research from now on is like, first in this study, I successfully isolate and study a large unrepresentative group of the far right cyanobacteria. And those cyanobacteria are widely distributed in the nature. And also this right shift chlorophyll D and F are extensively present in extreme and shaded environment. So maybe now you can answer the question, can photosynthesis occur in dark condition? And of course the answer is yes, they can still use far right light, which our human eyes cannot see it. It's very dramatic. Yeah, and here I will thank all of my colleagues from FU Berlin University, and thank you my supervisor, Dr. Dennis Newbeck, and special thanks of Dr. Daniel from Liverpool University to collect the sample at the beginning. And that's all, thank you.
So basically, we don't have so much time left, unfortunately. Therefore, I would like to invite Cammack and Ira here as well for maybe like a 7-minute, 8-minute question session, because we want to move on with a little tour of students tour here before we have a coffee break. Therefore, we have like a 7-10 minutes for questions. So if you have any questions, please come forward. Any questions from the room, please come forward. Then I will start. Okay, then I am actually curious maybe how we can just interpret this situation. You said that actually, yes, okay, I don't know how to elaborate the question now. Because you already answered that. Okay, actually, the photosynthesis exists in the dark environment, but how beneficial this could be for future, actually, because under certain climate crisis, how this could be an interesting possibility for other human and non-human organisms to look at this cyanobacteria, because it could be toxic, but at the same time it is beneficial as well. So, well, why you were interested in this perspective?
Yeah, thank you for your question. It's a very good one. So I may explain it a little bit well. Like as I thought, it's a very primary producer. It can use this far-right light. That means it more photon or more light, not only visible light, can be used for the photosynthesis, but also the far-right light. What's this special part of the far-right light? Because a lot of places are shaded, like maybe you heard about the vertical farming system. They want to use limited space to grow more plants. And it's also the same because there's a lot of competition in the nature. So when this organism can use far-right light as the photosynthesis, that means it do not have to live directly under the sunlight. They can still live inside of the soil, inside of sandy. They have a new niches in the earth. So that's their kind of different power or different energy resource comes from. And when talk about this potential ability, furthermore, like this one has very huge potential, can be used for maybe Mars immigration, because these cyanobacteria are very tolerant organism. So, and also NASA already work a lot of experiment with cyanobacteria. They put them into the space and let them grow or to see what's happened on them. If they can use this far-right light, that means future when we move to another planet, it may help, really. So yeah, because the atmospheres in another place or outside of space is quite different from the Earth. So that if they can use different light, that means we kind of improve our ability for living in the future. Thank you.
Thank you so much. Is there any other comments, questions from please? You can.
Yeah, I'm not sure if it's a question or a comment, but I think it would be good to remember that before cyanobacteria, there were other anaerobic organisms that cyanobacteria poisoned to death by producing oxygen. And we need to acknowledge that. Yeah. Thank you.
Thank you so much. Do you have any questions to each other, actually, since a scientist and artist are coming together? Maybe this is also an interesting possibility for them to just have a kind of a conversation. If you don't have any question from the room. You don't have to.
I don't think you said this. Why you became interested in studying specifically the cyanobacteria from extreme environments that absorb the far?
Yeah, it's kind of also because when I'm looking for the PhD, I just find this project is really interesting. Like I I work with microalgae, which called oh, sorry, I forgot the name, but it's not cyanobacteria, but I worked with microalgae before, which beneficial in the agriculture. And later when I say, okay, this topic is really interesting because as a biologist, I never think about the photosynthesis can use invisible light. It's also unbelievable for me at the beginning. So I decided, okay, I want to study more. I want to learn how this process done or how these new pigments happening in this dramatic organism. Still, there's a lot of unknown things under it. So we are kind of like exploring them and hope to understand more about these things in the future. Thank you.
I have a question for Ira and Cammack, actually, because in your both works, there's a very strong storytelling. And can you actually a little bit expand on the storytelling? Because both of you were telling the whole process of the project, but the storytelling section stayed a little bit limited in the presentations. Maybe we can use this like a discussion opportunity to talk about the storytelling part of the project.
Yeah, that's actually the question I want to ask. Because like you saw it, our both project exactly. So we bring also like the storytelling. I bring the myth and you brought the storytelling that popular among. And I don't. For me, it's actually kind of like become like a good narrative, and it's like it's kind of like the story of the symbiosis. So this there is this myth and there is this scientific background that can be merged actually and can be applied for the use for daily life and for the future, like you said. But I also want to know from the scientific perspective, like about that.
Okay, so you want to know like more into detail of this symbiotic relationship between this. Myself.
The question. No, but I was more interested in how your artistic practices narrates this like a stories. It's embedded, but that was not really, we didn't have a chance to talk much.
Okay, she changed it now. So what are your stories?
Your stories.
But I actually think what you were saying was interesting too. I can talk because then I also once was talking to someone else who's a scientist about how they see their own maybe not scientific stories within their scientific work. And do you ever think of stories when you're doing your practice? I can also talk. Do you want to answer first? To talk about my story. I'll go short. Yes, so then I wanted, from what I talked about in the presentation, how to bring these stories together. So I've made this fictionalized narrative that's set in a factory where they're producing products that are made from cyanobacteria. And actually now it's transforming into a whole musical that I'm really excited for. And actually it's what I'll do on the 7th of July with a friend. And together we kind of create her character as well, because I have the songs and the story, but we will create together the backstory. And she's like the artist and I'm the factory worker, because the idea is that there's a gallery next door to the factory and they are confronted with each other, art and science.
Maybe I have a little question for you. Like I heard you use Staphylococcus for your Cyanobacteria. So why did you choose that stream, or like just you got it by in coincidence?
It's what I could find on eBay at the time.
Next time, tell me. I can provide you.
I love eBay.
Okay. eBay even can buy Cyanobacteria. Okay, I will find them.
Okay, if you don't have any questions or comments from the room, actually, I would like to welcome back Professor Dr. Misha Christen to just continue with the end of this panel.
So first of all, I think thank you so much for your presentations and for the discussion. I think we can start first by giving them a hand.